In this video, we will be talking about the mathematics of weight. Weight is a force that is exerted by a mass because of gravity. A force is a push or a pull. There are many types of forces. Gravity is a pulling type of force that every object exerts on every other object. Scientists are only just starting to learn what causes gravity, but we've known its effects for a very long time. Pause the video for a moment and draw arrows to model the pull of gravity between the Earth and Grumpy Kitty. We will sometimes talk about a gravitational field. This is just the region of space around an object that has gravity. The gravitational field surrounds the object in 3 dimensions. Other objects will be affected by gravity no matter where they are in that field. Objects with more mass have stronger gravitational fields than objects with less mass. That's why you would weigh more on Jupiter than you would on Mercury. For example, say you have a 100-pound 7th grade student. On Mercury, that student would weigh 38 pounds, but on Jupiter, the student would weigh 250 pounds. Gravitational acceleration, which is given the symbol lowercase g, is a term used in physics to show how strong a gravitational field is. On Earth, gravitational acceleration is defined as 9.8 meters per second squared. We can use an equation to show the relationship between mass and force. The equation looks like this. F equals ma, where the F stands for force, the m stands for mass, and the a stands for acceleration. This equation is used for many types of forces, including the force of gravity. When we're considering the weight of an object on Earth, which is the force of gravity on the object, we can think of the equation like this. The F stands for weight. Remember, weight is the force of gravity pulling down on an object. M stands for the mass of the object, and that lowercase a stands for the gravitational acceleration, which on Earth is 9.8 meters per second squared, but may be a little different on other planets. In a moment, we're going to use this equation, but I want to give you a heads up. When you use equations in science, it is very important to remember to always include the units in your calculations. That's why we've kept our units in the example. The SI unit for mass is the kilogram, and the SI unit for weight is the Newton, and those are going to be in our equations. Let's work through an example. The mass of a dog is 18 kilograms. What is the dog's weight on Earth? When you are working a problem in chemistry, the first thing you want to do is to set up your problem. Let's start with what we know. From the question prompt, we know that mass equals 18 kilograms. We also know that the acceleration due to gravity on Earth is 9.8 meters per second squared. The second thing we have to figure out is what we need to find. And we see from the prompt that we've been asked to find weight. Now that we have all the values, what we need to do is put them in the equation. F is what we need to find. Now we are going to take our 18 kilograms and we're going to bring it down here and substitute it in for the little m, which stands for mass. We're just going to bring that down. Now we're going to take our acceleration due to gravity, that's little a, 9.8 meters per second squared, and we're just going to bring it down and put it here in the equation where the lowercase a is. Now our equation looks like this. What we're going to do is we're going to multiply the 18 by the 9.8 and we're going to get 176.4. Our unit for force is newtons, and we're going to make sure to write that down here. This next example is a little different. If you're given the weight of the object and the acceleration due to gravity, 9.8 meters per second squared, you can find the mass by rearranging this equation using algebra. If you already know algebra, I encourage you to try this out. But if this is all new to you, just know that you would be given the equation in this format on any worksheets or tests. We're going to use it in a very similar way to the way we use the F equals ma equation. Let's show you this by using an example. The weight of this bag of candy is 4.9 newtons. What is its mass? The first thing we need to do is to set up our problem. What do we already know? Well, from the prompt we know that the force of gravity, or the weight, is 4.9 newtons. And we also know that the acceleration due to gravity is 9.8 meters per second squared. And we're going to assume that this is on Earth because they haven't told us it's on a different planet. Now we have to determine what we need to find, and this prompt has asked us to find mass. Now we will take our values and we will plug them into the equation and solve. So we can take our force, the 4.9 newtons, and we are going to swap it in for that capital F variable like this. Now we're going to take our acceleration, 9.8 meters per second squared, and we're going to put it right down here, substitute it in for this little a. Notice that we have kept our units in the equation. We are going to divide 4.9 by 9.8. We can use a calculator to do this, and we get 0.5. Now we know that the unit for mass is kilograms, so that's what we're going to write here. So now you should be able to explain how mass and weight and gravity are related mathematically and be able to use the force equation F equals ma to calculate the weight of an object that you know the mass of.